Here we are with the week 13 video, week 13. And this week we start with some dividing of fractions. So remember our rule. When we have a fraction division problem, we think about it like a multiplication problem, which means that we keep the number we start with. We can't change the 2/3. That's what we have. And then we're dividing something up. We're dividing 2/3 into pieces that are each 1/6 in size. And the way that we actually do it is we multiply by the reciprocal. The reciprocal of 1/6, let's just do this up here really quick. The reciprocal of 1/6 is the number that you would multiply it by to get 1 whole. Now, in this case, the 1 whole, let me just do that a little bit differently, would look like 6/6. So the reciprocal of 1/6 is 6/1, and we multiply our 2/3 by 6/1. We can cancel before we do the multiplication. We can divide 6 by 3. 3 goes into 6 twice, and 3 goes into 3 once. And then we have 2 times 2 is 4. 1 times 1 is 1. That has a value of 4. That's the answer to our first one. Next one. Now here, before we can change it into a multiplication problem, we need to go ahead and change these both into improper fractions. So we're going to make this into an improper fraction. Here's what we know. We know that the number 1 has 6/6 in it. So this is 6/6 right here. This is 6/6 right here, plus another 1/6 that we had left over for a total of 7/6. Now the shorthand way of doing that, the shortcut that you learn, is take the big number, the whole number, times the denominator, so 1 times 6. That tells you, right here again up top, that tells you how many sixths are in 1 whole. And then add the numerator and keep it all over the original denominator. So 1 times 6 is 6, plus 1 more is 7. So we've got 7/6 divided by, we do the same thing with the 4 2/3. So for 4 2/3, that would be 4 times 3, that tells you how many thirds there are in the whole number 4, plus 2 more. So 4 times 3 is 12, plus 2 more is 14/3. So we'd be dividing by 14/3. Now, just like last problem, we're going to actually multiply by the reciprocal. So we're going to keep the 7/6. That's what we have. We can't change what we have, but we can change what we do to it. So instead of dividing by 14/3, we're going to multiply by 3/14. We're going to go through the canceling process again. 7 goes into 7 one time. 7 goes into 14 twice. 3 goes into 3 once. 3 goes into 6 twice. We get 1 times 1 is 1. 2 times 2 is 4. And we end up with 1/4. That is our answer to the problem. What is 1 1/6 divided by 4 2/3? 4 2/3 can go into 1 1/6, 1/4 of a time. Down to 1C. We need a number that times 5/6 is going to be greater than 5/6. Well, here's what we know. We know that if we did 5/6 times 1, we would get 5/6. So we want it bigger than 5/6, so this needs to be bigger than 1 whole. It can be any improper fraction. I'm going to use 4/3. And let me prove to you that it's bigger. So then we're going to have 5/6 times 4/3. I can go ahead and cancel. 4 can be divided by 2 twice. 6 can be divided by 2 3 times. And I end up with 10/9. And 10/9 is greater than 5/6. Now, just in case you don't believe me that 10/9 is greater than 5/6, I will prove it to you. I'm going to make each of these numbers an equivalent denominator, and it's going to end up being 18 because 9 and 6 both go into 18. So 9 goes into 18 twice, so 10 times 2 is 20. 6 goes into 18 3 times. 5 times 3 is 15. And now that the denominators are the same, you can see that 20/18 is greater than 15/18. Some of you might have stopped back at this point and said, well, you don't even need to do that for me because 10/9 is bigger than 1 and 5/6 is less than 1. That's another way to look at it. So either one of these is your proof. On this one, one's bigger than 1, one's less than 1. You don't need to go further. But if they were both less than 1, you could use this to prove it. All right, so that takes us then to 1D. So here, let's go back to this. Your answer here is anything, any number, anything greater than 1 whole. And any fraction greater than 1 whole is called an improper fraction. So your answer to 1C is going to be some improper fraction. 1D, 2/3 divided by something is greater than 2/3. Well, logically, if we had to multiply by more than 1, it's logical we would divide by less than 1. And I'll show you why that's going to work. Let's just get this out of the way for a minute. So we know about division problems. If we look back at these division problems, here's what we know. We know that we changed it into a multiplication problem. So think about this is going to get changed into multiplication. Well, we know when we multiply, it has to be some number greater than 1. Since we're going to multiply by the reciprocal, what we want to do is we want to make this less than 1. So let's make it 3/4. Because when we change it to a multiplication problem, 2/3 times, this is going to end up being 4/3. And we already know, as long as we're some number greater than 1 whole, like this 4/3 now, we're going to end up with a number bigger than what we started with. So let's play this out. Let's just see how this works. We're going to end up with 2 times 4 is 8. 3 times 3 is 9. And 8/9 is greater than 2/3. And if I use my method from the last one to prove it by making everything the same, the 8/9 doesn't have to change. We're going to change this into 9. So 3 times 3 make 9. 2 times 3 makes 6. And 8/9 is greater than 6/9. So here we need anything less than 1 whole. That's our answer. So you could have any fraction less than 1 whole. And we think of those as proper fractions or regular fractions as opposed to improper fractions. Okay, so review this section pretty well because you're going to see this same sort of thing coming up on the next test. If you didn't do well on it this test, but you took good notes, that's okay. You got your 3 points. Now the next test is the one where you'll really shine on this. Okay, on to the next part. So here we go. We've got 4 mixed number addition and subtraction problems. And they might look kind of formidable, but really these 4 problems, if you think them through, you don't need a lot of fancy working with changing things to improper fractions. You can certainly do that, but you can also do them logically. So we're going to use the rules that we learned about integers. I'll scroll back up so we can see the number line in a minute. But we're going to use our integer rules. And our first thing here is we're going to change this into 6 1/2 plus 5. Or negative 6 1/2, excuse me, plus 5. Instead of subtracting a negative, we're going to do what we did back with integers. We're going to add a positive. From this point, there are a couple of ways that you can solve this. One way would be to change both of these to improper fractions. So let's do that. 6 times 2 is 12, and 1 more is 13. So we have 13 over 2 plus, we need 5 in halves now. So think of it as 5. If you divided 5 into halves, each piece into a half, each one is going to be 2 halves. So altogether it's going to be 10 halves. Now you've got negative 13 plus positive 10. That's 10 zero pairs. We get negative 3 halves, which is negative 1 and 1 half. That's our answer, negative 1 and 1 half. You might have also looked at this and said, well, here's the problem that I have. I have negative 6.5 plus 5. 5 of these positives will cancel out 5 of those negatives, which leaves 1 and 1 half left. There's our answer, negative 1.5. Letter B. The most common wrong answer on letter B was 0. But you're not taking away the same thing. The only way to get 0 is to take the same thing away. In fact, let's jump down to C. C is actually 0. We have negative 2 1/4. We add its opposite. Anytime you add opposites, they equal 0. So there's your 0 answer, C. Up here, for B, we're going to do the same thing we did on A. We're going to change it to an addition problem. So instead of taking away positive 1 and 1 half, we're going to add negative 1 and 1 half. Now everything's negative, so we have negative 1 and 1 half plus another negative 1 and 1 half. You could change these if you'd like to into improper fractions. Negative 3 over 2 plus negative 3 over 2 equals negative 6 over 2. And 6 divided by 2 gives us our answer, which is negative 3. So there's the answer to that one. 0 was the answer to that. Or you might just look at this and say, well, if I have 1 and 1 half and I add another 1 and 1 half, I have 3. And since everything's negative here, I'm going to have more negatives. The rule you don't want to fall into, the one you don't want to make the mistake, is where you say, oh, I've got 2 negatives, they make a positive. That's only in multiplication and division, not in addition and subtraction. Letter D. So let's go through and use the improper fraction method again here. So we have 2 and 1/4. So 2 times 4 is 8, plus 1 more is 9. So we have negative 9/4. And we're going to add 5 times 2 is 10, plus 1 more is 11 halves. Now we know that anytime we're adding fractions, we have to have common denominators, and 2 and 4 can both go into 4. So our negative 9/4 will not change, but our 11 halves need to become fourths. So 2 times 2 made 4, so 11 times 2 is 22/4. Now we have 9 negatives and 22 positives. That's 9 zero pairs. So these 9 negatives cancel out 9 of the positives here, and that leaves us with 13 positives. And now we're going to change this back to a mixed number. 4 can go into 13. 3 times, that's 12. 13 minus 12 is 1 left over. 3 and 1/4. So let's take those now, and let's put them all right back up here. So A, negative 1.5. C, 0. B, negative 3. D, 3 and 1/4. And now we can start moving them into our number line. So negative 1.5, the value for A, well, there's negative 1, so there's negative 1.5. B, negative 3, negative 1, 2, 3. There's B. C is the 0, and D is 3 1/4. And I just need to change that to a letter instead of the 0. So there you go. All right, so again, you're going to see similar problems, addition and subtraction of mixed numbers on this next test. Please take time to review this and make sure that you ask some questions if you have questions. All right, closing out the test here. Numbers 3 and 4. So on number 3, we have 3/4, and we're adding another 3/4, so that gives us 1, 2, 3, 4, 5, 6 of them all together. I'll put a couple lines through these because we can see each of these is a 1 and each of these is a 4th, or is a half, excuse me. So we end up with 6/4, which simplifies to 3/2, which simplifies to 1 1/2. We can see we have 1. Here we have 4/4, which is the same as 1. And here we have 2/4, which is the same as a half. Number 7. We have 7/8, 1, 2, 3, 4, 5, 6, and 7. And we are subtracting 5/8, 1, 2, 3, 4, 5. So we're going to take those out of that, 3, 4, 5. And that leaves us with 2/8. And that 2/8 can be simplified. I almost wrote the wrong thing. To 1/4. So our answers for 3 was 1 1/2. For 4 was 1/4. And our final problem on the very bottom. So the temperature at 5 a.m. was -13. It rose 18 degrees by noon. What was the temperature at noon? So we're going to build a thermometer. I'm going to use this space up here. Build a thermometer. There is 0 degrees. We know that at 5 a.m. it was -13 degrees. And we know that during the course of the day, it rose 18 degrees. So it went up 18 degrees. So where did it stop? Where did it end up? Well, here's 13 degrees to get from -13 to 0. So there's 13 of that. There's a 13 degree increase. So out of an 18 degree increase, and I'm sorry I put a negative sign there, that was a mistake. Out of an 18 degree increase, there's another 5 degrees to go up, and that is our closing temperature. 5 degrees was the temperature at noon. Ouch, still pretty cold. Okay, so now you've got a bunch of stuff. You can read over this, listen to this, replay it if you need to replay it. Please take the time to look this over so that you're that much more prepared when you come in for with the week 14 test, which is going to have a lot of the same stuff. All right, see you in class.